So the last part, number 3, asks to manually sketch a plot of aluminum concentration in FCC-A1 phase versus temperature for aluminum 5% zinc alloy. So here we're going to look at the 0.05 Zn mark, and the point to look at for our y-axis of the plot is the aluminum concentration, which would be the leftmost side, like this line right here. Although it says 0 moles of zinc, that would be 1 mole of aluminum. And the FCC A1 phase is solely by itself in this region, and in this spot right here is where you have FCC A1 plus HCP A3, and then the liquid plus FCC A1 region right here. So we have 3 different regions to look at for the FCC A1. So we'll start right at the bottom, and we're going to use the lever rule partially to show the concentration of FCC A1 at specific points. So here, where we have FCC A1 plus HCP A3, we'll start at temperature of 300. So right at this point right here, we're gonna look at our line to the left, and this line right here is the FCC A1 line. So here is measured with zooming in, it's 0.006 moles of zinc. So what we're going to do is we're going to subtract 1 minus the moles of zinc to get the moles of aluminum. So for temperature at 300 Kelvin, for FCC A1, we're going to note the moles of zinc because that's our x-axis on the phase diagram, and then the moles of aluminum. And how we're getting moles of aluminum, 1 minus moles of zinc equals the moles of aluminum. So at 300, we said it was 0.006, and if you do 1 minus that value, we get 0.994. All right, so in this region, it goes from FCC A1 plus HCP A3 up to this region right here, which is about 460 degrees Kelvin. And then at this point is when it's only FCC A1. So here, looking at this region, we know for the entire block from 460 to 890, we only have one phase, FCC A1. So in this entire region, we don't have to use the tie line because there's only one thing present. So if there's only FCC A1 present here, then we follow the composition of 0.05 zinc. So since we have 0.05 zinc, 1 minus that would make 0.95 aluminum. So we'll write that in our chart of temperatures. So the beginning region of that was 460 Kelvin, which goes to 890 Kelvin. And it's the same between both of them. So you have 0.05 zinc and 0.95. And same for both endpoints and within the region, just because it's a single phase region for that component. So we just looked at the entire single region FCC A1, but once we hit this point right up here, we have 890. And then after 890 to about 930 is where we have two phases in the temperature range, liquid and the FCC A1. So at this point, we have just FCC A1, but we'll look at the next temperature, 930, below it, and then above 930. So at 930, we'll make a tie line where you drag it along to this line right here. This is the FCC A1 contribution. So you bring it along over. When you bring it down, it's about 0.02. That's just by eyeballing it. I'm not sure exactly what it is, but you'll just guess what percentage of zinc is right around here. So when we write that down, below the 930 mark, we have 0.02 moles of zinc, which sums up to 0.98 moles of aluminum. So now that we looked below the 930 Kelvin, we can look above the 930, which is just the liquid phase. So here we have above 930, 0 moles of zinc and 0 moles of aluminum, because there is no FCC-A1 available. It's just a single region, which is liquid. So we'll write that here. Above 930 Kelvin, 0 moles of zinc, 0 moles of aluminum, and that's because of the cutoff range where no FCC-A1 is present, because it decreases as the temperature increases, or FCC-A1 decreases as temperature increases. So here we have our values of temperature and moles of aluminum, and this is assuming that concentration of Al plus the concentration of zinc is equal to 1. So that way our axes are in check. So we'll do the x-axis region, do the labels, and the y-axis, we're going to look at the aluminum column over here. So I'm just going to put 0 here, and then a little squiggle bar, just because most of our values here are above 0.9, but we still have the 0 here. So we'll just do value of 0.994, then 0.98, and then 0.95. So we have at 300 Kelvin the 0.994, so we'll note that there. And then 460 Kelvin, right around here, has the 0.95. So we'll note that value and connect it since it decreases. It doesn't actually decrease linearly. There is a concavity. It would be concave down, because if you look at the graph from this region, the delta aluminum at the start is minimal. It's less than the delta aluminum at this region over here. So if you wanted to include concavity based off of values, it would be concave down, but we'll just use the linear version for simplicity. So linearly, or in general, it decreases. And then from 460 to 890, since it's the single region of FCC-A1, we will just note that value and do a horizontal line connecting. All right, and last part, 930 Kelvin. We have 0.98 at the 930 mark, which increases, and then once it hits 930, there is no FCC-A1 present because it's just the liquid phase. So it drops down to 0, make a vertical line, and as temperature increases, the FCC-A1 is still not present. So this is how you would do the aluminum concentration in FCC A1 versus temperature at 5% zinc for the Al-Zn phase diagram, which is over here.